Hello everyone, and welcome to this video titled Algebra Expressions with Fraction Bars. In this video, I'm going to be going over several examples taken directly from the website ck12.org. Alright, so here I am at ck12.org's practice for algebra expressions with fraction bars. I'll be going through just the first 5 of these examples in the practice here. I'll leave it to you to go to this site and practice further on your own if you wish. And I would recommend that as soon as I start one practice problem, one example, pause the video and try to work it out yourself before seeing how I'm doing it. Okay, so in this first example, we're asked to use the order of operations to evaluate the following expression. So we have two fractions, right? Two expressions with fraction bars. The first fraction above the bar is 4 plus 7 times 3. Below the bar is 9 minus 4. Then we have plus, and then a second fraction above the bar is 12 minus 3 times 2. Below the bar is 2. Now, I'll open up the scratch pad. When you're working with expressions with fraction bars, right, division symbols, the fraction bars you treat almost as if they were grouping symbols, right? They're like parentheses. They separate parts of the expression that you should simplify first before continuing. So for example here, right, the first fraction in this expression has above the fraction bar, in the numerator, it has 4 plus and then 7 times 3, right? And then the fraction bar. And then below the fraction bar in the denominator, 9 minus 4, right? And then we have plus, and then 12 minus 3 times 2 over 2. Right? So plus, and then another fraction with 12 minus 3 times 2, and then divided by, 2. Okay. Just want to make doubly sure that I copy that correctly. Good. All right, so as I was saying, treat fraction bars as if they were grouping symbols. This is just like having parentheses around this numerator and around this denominator. Same thing for this other fraction bar. It's like having parentheses around the numerator and around the denominator. Now the denominator is just the number 2, so there's really no need for the parentheses around it. Apologize for that. But the other stuff we do need to simplify, following the order of operations. So remember your order of operations, I'll write the little acronym over here, right? One of them was, PEMDAS, PEMDAS, where you're working in parentheses or grouping symbols first. E for exponents, things with powers. M and D were multiplication and division from left to right as you see them happening. And then finally, addition and subtraction, right, or the A and S from left to right as you see them happening. So in this expression, right, the first things I'm going to work at are simplifying the expressions above and below fraction bars, right, working inside the parentheses, if you will, inside the grouping symbols. So this first fraction, 4 plus 7 times 3, I'm looking at 4 plus 7 times 3. The first thing I'm doing in there is the multiplication. So that'd be 4 plus, and then 7 times 3 is 21. And then, 4 plus 21 is 25. All right, so that's the numerator of the first fraction. And so you got the fraction, then you got the fraction bar still. And then in the denominator of the first fraction, 9 minus 4, that's just 5. And so we have 25 divided by 5 for this first fraction, and we will simplify that in a minute. 5 does go into 25 evenly, but we'll get there in a minute. Right, plus, and then I do the very same thing for the next fraction. Right, above the bar is the expression 12 minus 3 times 2. So I'm doing the multiplication first, right? That becomes 12 minus, and then 3 times 2 is 6. All right, fraction bar. And then 12 minus 6, so we got plus, and then 12 minus 6 is 6, right? So that numerator simplifies to 6, and the denominator was always just the number 2. Okay. But now we have some fractions that can be simplified, right? The numerator and denominator have common factors. In the first fraction, right, it's 25 over 5, 25 divided by 5. That's 5, right? 5 goes into 25 5 times. So that first fraction simplifies to 5. Then we have plus, and then 6 divided by 2 for the second fraction, that is 3. And then 5 plus 3 finally simplifies to 8. All right, so the value of this expression we were first given is 8. And some of the choices up here, let's B, and we will check it out. And it is correct. Yeah. Alrighty. So let's move on to the next example. All right, so this one is an example where you have to substitute values for variables and then simplify, but it's still the same concept. The fraction bar you can think of as a wall, or like your parentheses or grouping symbols. Everything above the fraction bar, right, the numerator, I'm going to simplify that first, and then everything below it, the denominator, I'll simplify next, and then we'll do the division. We'll see if we can simplify the fraction any further. All right, so here we have x plus y squared divided by y minus x. So I'll write that. We have the expression x plus y squared, right? So that's above the fraction bar, right? That's in the numerator. Over or divided by y minus x. All right, so just like I was saying a second ago, this is just like having this. Above the bar, we're going to simplify that, right? Go inside that. Imagine there's a set of parentheses around it. And below the bar, same thing. We're going to go inside that denominator and imagine there's a set of parentheses around that and simplify that, and then we'll simplify the fraction. And we're asked to evaluate this when the value of x is 2 and the value of the variable y is 3. All right, so write that here, right? When x is replaced with the number 2, y is replaced by the number 3. All right, so let's do that. All right, so I'm going to take this over here. So in the numerator we have, 2 plus, and then this y is being squared, right? So there's something happening other than just y. So I'll put parentheses around it. If it's being multiplied by something or raised to some power, I like putting, parentheses around when I replace in those cases. So 3 squared, this is divided by or over, and then you just have simply y, which is 3, minus, and then x, which is 2. All right, so like I was saying, first I'm going to simplify the numerator, right? Everything above the fraction bar. So I go up there. The first thing I'm doing is the exponent, right? So that's 2 plus, and then 3 to the second power. That's 3 times 3. That's 9. Over, and then 2 plus 9. That's all there's left to do in the numerator. 2 plus 9 is 11. And so I'm done with the numerator. That simplifies to 11. And the denominator is simply 3 minus 2, which is 1. And, so that's the denominator still. And then any number divided by 1 is itself. Right? So 11 divided by 1 is 11. So this expression they gave us when x was 2 and y was 3 has a value of 11, which was choice C here. And let's check it out. Excellent. All right, let's keep going. Alrighty. So now this one again involves division. One thing I want to point out here is that any division symbol you see like this with the obelisk symbol, it's a little line with a dot above and below it. This is the division symbol or obelisk symbol. Uh, whenever you see that symbol, you can rewrite the problem as a multiplication problem. All right, so what we have here, I'll show you. All right, we have 4/7, right, the fraction 4 over 7, and divided by, right, this division symbol, and then 8/5. 8/5. So as I was saying, every time you see a division symbol, right, this symbol here, divide, is the same as multiplying by the reciprocal of the fraction after it, of the fraction to the right of it. Now the reciprocal means, just flip the fraction over. The reciprocal of 8/5 here, right, this fraction after the division symbol. The reciprocal of 8 over 5 would be 5 over 8. So I can take any time I see a division problem with the division symbol like this and rewrite it as, 4/7, right? The first fraction's not being changed. What's being changed is what we're dividing by. Change it to times, right? Change division to times, and then the fraction we're dividing by, we're going to multiply by its reciprocal. So instead of divided by 8/5, we have times 5/8. And those are equivalent, right? Dividing is the same as multiplying by the reciprocal. Okay, now, when you multiply numbers, when you multiply fractions, you simply multiply the numerators to get the new numerator, right? So we have 4 times 5, that's 20, right? So the numerator is 20. And you multiply the denominators. 7 times 8 is 56. So 20 over 56 is the value of this expression, 20/56. But we are also asked to write this in simplified form. So I would like to find if the numerator and denominator have any common factors. Are there any numbers that go into 20 and to 56 evenly? Well, they're both even, right? So they both have 2 as a common factor, right? 20 is 2 times 10. 56 is 2 times 28. And then I can cancel, the 2's, right? 2 over 2. If the numerator and denominator of an expression have a common factor, they divide out to be 1. 2 divided by 2 is 1. So now I'm left with 10 28ths. Oops, let me change the color back. All right, so now I'm left with 10 28ths. But, 10 and 28 also have a common factor of 2. They're both even as well. 10 is 2 times 5. 28 is 2 times 14. All right, so once again, I see the common factor in the numerator and denominator of 2. Those will become 1. Get rid of those. And we're left with the final fraction, the simplified fraction of 5/14. Right, and 5 is 5 times 1. 14 is 2 times 7. They have no common factors. Right, so this is it right here. This is what they're asking us for, right? The final result, the final value of 4/7 divided by 8/5 as a simplified fraction. So I'm going to enter here, and they say enter as a reduced, improper fraction. 5/14. Now, 5/14 is actually a proper fraction. The numerator is smaller than the denominator. Be careful, an improper fraction is one where the numerator is larger than the denominator, right? The value of the thing is larger than 1. So I think they messed up a little bit with the wording there. Let's check it out. Wonderful. All right, so next example. All right, oh boy, quite a big one here. But still the same procedure. I'm going to replace all the values of x anywhere I see x in this expression with the number -4. Replace all the z's with the number 5. And above the fraction bar, we'll simplify that with the order of operations. Below the fraction bar, do the same. All right, use the order of operations to simplify. All right, so I'm going to work with this one at a time. So the numerator is, x cubed, right, x to the third power minus z squared. All right, so here's the numerator. All right, this is the stuff above the fraction bar. And we have x to the third power minus, z to the second power. And the value of x, they told us, was -4. Okay. And the value of z is 5, +5. All right, so let's simplify this. I plug these in, right? So now they're being raised to powers, so I'm going to put parentheses around what we replace. All right, if your variable is being multiplied by something or raised to some power, I would recommend putting parentheses around what you replace. All right, so this is -4, to the third power minus, and then the value of z is 5, right? And this is being raised to the second power. Now, running through the order of operations, right, we're going to raise these powers first, right? Do these exponents first. Now, -4 to the third power, that's -4 times -4 times -4. All right, now that would be -64. All right, -4 times -4 is +16. Then times -4 again would be -64. And we still have the minus, right? Minus, and then 5 squared, 5 times 5 is 25. And then now all we're doing is subtracting. -64 minus 25 would be -89. Right. So that's the numerator. That's the numerator. And then then we have our fraction bar, right? I know you don't put everything over here over the fraction bar, but then the denominator is this expression. You have x times z minus 3 times x times the quantity z minus x. So now we're going to the denominator. I'll just put denom, right? So it's x times z and then minus, and I believe it was 3x times the quantity z minus x. Yes. Right. So minus 3 times x times the quantity z minus x. All right, and once again, the value of x is -4, value of z is 5. So I will make those substitutions. So here we have some multiplication. So I'm going to again put parentheses around these, right? They're being the variables are being multiplied by something or raised to powers. So I would highly recommend, putting parentheses in those cases. Or if it's being subtracted as well. I mean, basically just get in the habit of putting parentheses around what you replace. Okay. So -4 times 5, and then we have minus, 3 times x is replaced by -4, and then multiplied by, and then inside this set of parentheses here, we have a difference, z is 5, minus, and then x is -4. Again, if it's the only time I don't put parentheses around my replacement is if it's got a coefficient, if it's being multiplied by +1. Right, that's the only time I never put parentheses. Every other time, if it's being subtracted, or multiplied by -2, -1, 5, or raised to powers, put parentheses around it. All right, so following the order of operations here, all right, the first thing I'm going to do is go inside this set of parentheses. I know there's a lot of parentheses, but this set of parentheses has some operations to do. Now remember, 5 minus -4, that's the same as 5 plus 4, right? Minus a negative. -1 times -1, that's +4. So that's 9. So we have -4 times 5, then minus 3 times -4, and then inside the parentheses here, it was 5 plus 4, that's 9. All right, now I have some multiplication to do, right? There are no exponents. So now I'm going to be doing -4 times 5, right? We're going left to right and just multiplying, right? -4 times 5 in the first term, that's -20. And then we have, minus, and then here a big product. I'll just multiply all three of these. 3 times -4 is -12. And then -12 times +9 would be -108. All right. And we're subtracting this. Right. So -108. And then here we have, finally a subtraction to do. Well, it really turns into an addition, right? Because you have minus and negative here, which would be plus. So this is -20 plus 108, right? -20 plus 108, or 108 minus 20. 108 minus 20 is 88. All right, so the fraction, when all is said and done here, is -89 divided by +88, and that is good, right? 89 and 88 do not have any common factors. Now, based on the choices we're given, though, it looks like they're having us write the answer as a mixed number, right? Where you have the whole number and then the fraction part left over. So this here, this is negative, obviously. And then 88 goes into 89 one time, right? With 1 left over. So 88 goes into 89 once with 188 left over. Right? So as a mixed number, you would write it this way. Right? Now you gotta be careful with mixed numbers. This means -1, minus 188 to make -89, 88. Very often people will mess this up and think of this as multiplication because they're touching, but this is a mixed number. Look up some mixed number problems to maybe get some more practice with those, right? Anyway, the solution here, the value finally is -1 and 188th, or -89/88, and that was choice D. Wonderful. All right, and then finally, all right, like I said, I'm going to go through half of these practice problems. Let's see, another division problem. Where, remember when I said in example 2, I believe it was example 3, my apologies. Anytime you see this division symbol, uh, and there's no other grouping symbols, right? If there's no other parentheses to take you to something that's more important, you can, so there's no parentheses here. So I can take this division and this division and rewrite them as multiplication by the reciprocal. So let me show what I mean, right? So I'll write this out. So the first fraction I'm not really going to do much with. It's going to stay as 9/10, right? 9 over 10. And then we have divided by 4/5. And then we have divided by 1/3. So as I was saying, all these division symbols we can rewrite as multiplication by the reciprocal. This is the same thing as 9/10 times 5/4. Right, and then you have this divided by 1/3. That's the same thing as times, 3/1. Okay, all right. So yeah, again there were if there were parentheses around some of these, I would do one of them first, or if there was a divided by a sum or whatever, it could get more complicated. But if it's just simply divides, you can rewrite the division as multiplication by the reciprocal. So now that I've done this, change this to a multiplication problem. Remember in example 3, when you multiply fractions, you simply multiply the numerators, multiply the denominators, and then simplify if necessary. Well, 9 times 5 times 3, you know, I'll say 9 times 5 is 45, and then 45 times 3, that's 120 plus 15, that's 135 in the numerator, right? So when I multiply the numerators there, it's 135. And then down in the denominators, 10 times 4 times 1, that's 40. Okay. And then they have common factors. Now you could have also seen they have a common factor in the beginning. All right, there is a 5 in the numerator as a factor, and 10 in the denominator you could write as 2 times 5, and then cancel the 5s. Well, so I'm noticing then that, 5 is a common factor here, right? The numerator is 5 times 27, right? That'd be 135. The denominator is 5 times 8, right? That's 40. And then the 5s cancel, and you're left with 27 eighths, right? 27 in the numerator, 8 in the denominator. And 27 is 3 times 3 times 3. 8 is 2 times 2 times 2. These have no common factors, right? So this is it. And this is how they want us to enter it as well, right? They said enter it. Now this is actually an improper fraction where the numerator is larger than the denominator. My example earlier where it ended up being 5/14, that's a proper fraction where the numerator is less than the denominator. But here, this is truly an improper fraction, and that's how they want us to enter, right? Enter your answer as a reduced improper fraction, 27 eighths. Check that out. Great. All right, and that is all I'm going to be doing here. As I said earlier, you can continue, go to this ck12.org. And I'm in specifically their Algebra 1 text and their Algebra 1 practice. And, go to the practice on algebra expression with fraction bars. And you can continue this. And even when you're done with the 10, you can practice even further than that, and, to your heart's content. All right. And I hope this helps you out with expressions involving fraction bars. And thank you very much for watching.